Today we're making Buckeyes, and to do that, we need 1½ cups of peanut butter, 1 cup of butter softened, half a teaspoon of vanilla extract, and 6 cups of confectioner's sugar. We mix that together to make a dough and then roll the dough into balls. Then we dip them in the 4 cups of semi-sweet chocolate chips that we've melted and then refrigerate.
Our recipe uses heat transfer in order to melt the one solid chocolate chips so that we can dip our balls of peanut butter in them. Now, we use 2 different types of heat transfer for our recipe, the first being convection. Now, as you can see, the flame is not actually touching the bottom of the pot. The heat is simply being transferred through the air, through the gas. And then, once again, through convection, it is heating the water, which is, once it reaches boiling point, creating steam to heat the bottom of this glass bowl, where we are then using conduction to melt the chocolate chips, which are touching the bottom of the bowl as the 2 solids touch each other and the vibration of molecules.
Speaking of heat, water and chocolate both have unique heating and cooling curves. Water becomes a solid at 0 degrees Celsius. At 0 degrees Celsius, it begins to melt. It remains a liquid until 100 degrees Celsius, where it begins to boil. The temperature stays constant while it boils until it begins to vaporize, any temperature above 100 degrees Celsius. Chocolate has its own special heating curve and special cooling curve, but it's very hard to determine based on the type of chocolate and the materials used to heat and cool it. Typically, chocolate is a solid until it begins to melt at 45 degrees Celsius. However, chocolate doesn't vaporize due to its consistency. Instead, it burns. This temperature can vary based on the way the chocolate is heated. Chocolate also has a cooling curve dependent on the type of chocolate. It typically begins to solidify at 16 degrees Celsius.
Next, we will be talking about cookware. Cookware is a type of material in shape of pot or pan chosen that is most appropriate for the type of cooking being done. Choosing the right cookware makes the food taste better and have a better texture. Some important things to take into account when choosing the proper material are thermal conductivity, heat capacity, and reactivity. Thermal conductivity is a material's ability to absorb heat and spread it evenly to all parts of the pot or pan. When you are done cooking, you place the bottom of the pot or pan directly on the gas or electric stove. So naturally, the bottom of the pot or pan will heat very quickly before anything else heats. Choosing cookware that has a high thermal conductivity will prevent the bottom of your food from burning and solidifying at the bottom of your pan. If you are unable to find material that has a high thermal conductivity rate, you can compensate and take extra steps to avoid burning your food. The fondue pot that we are using is stainless steel. Although stainless steel is not very thermally conductive, it is adequate for melting the chocolate. The heat is concentrated at the bottom of the pot, but once the chocolate is in contact with the heat, it moves evenly through the chocolate. Avoiding burning the chocolate is best done by keeping the chocolate on the stove for an appropriate amount of time. Taking the chocolate off the stove once it's done will stop it from being burned. Melting the chocolate on a low temperature also prevents burning it. Stirring it occasionally also helps spread the heat evenly. Heat capacity is the amount of heat needed to increase the temperature of something by 1 degree Celsius. Although stainless steel has a low thermal conductivity rate, it has one of the highest specific heat capacities, which makes it ideal for cooking. It heats quickly, which makes for a fast and easy cooking experience. As you saw, we were able to heat up the chocolate quickly without burning it. The pot cooled down quickly, which made for an easier cleanup. Reactivity is an important factor that chemists already consider for us consumers when making cookware. Using pure stainless steel would not be ideal for any kind of cooking. Simply adding salt to a meal could ruin the material permanently. The only way you can use pure stainless steel is to boil water, which isn't very helpful at all. Stainless steel products are almost always lined with aluminum or copper discs to alter the corroding effects that cooking can have on stainless steel. Our stainless steel pot is the ideal material to use for most everyday jobs in the kitchen. It is affordable, easy to clean, and the aluminum or copper that is added to it improves its thermal conductivity.
Bacteria exist everywhere in nature, even in refrigerators. Refrigerators are used to store perishable foods but don't kill the bacteria. Instead, the low temperature slows the reproduction of bacteria to preserve the foods for longer. Refrigerators are most safe when kept at below 40 degrees Fahrenheit. Bacteria grows exponentially at 41 degrees Fahrenheit to 140 degrees Fahrenheit. In this recipe, we refrigerate dough to cause a firming reaction with the fats in the peanut butter and butter. Most dietary fats don't have a single set freezing point or melting point, and can be either solid or liquid at room temperature. It is important to freeze the mixture to solidify the structure of the fats and make them solid. We do this in order to dip the balls in the chocolate. Refrigerators work by exchanging hot air with cold air. The chemicals circulating go from a high pressure to a low pressure, and therefore from a high temperature to a low temperature.